Welcome back. Today we continue our topic of the exponential growth and decay. There's our formula at the top that we learned on Tuesday and all of its parts. And what we're going to be doing is applying that formula today to some actual real-life problems. So let's look at our first real-life problem here. So the number of invasive carp in the local watershed is about 500 carp. I just made that up. It's not true, but if you went to the Eagle Marsh field trip, you know how invasive species, especially this Asian carp, can really affect business and commercial things like fishing. If that Asian carp were to get into the Great Lakes, it would essentially eat all of the food for the other fish would die, and a giant billion-dollar-a-year fishing industry would basically go bankrupt, all because of this one fish. So we got to keep this fish out of the Great Lakes. So we keep an eye on its numbers in other areas near the Great Lakes, like the Mississippi River, where this thing is now found. Anyway, Indiana, Fort Wayne right here happens to be a breaking point between the Mississippi River watershed and the Great Lakes watershed. So again, if those fish crossed over the Fort Wayne barrier, then they could get into the Great Lakes. So definitely, again, something we really are concerned about. So it says the carp population is growing at a yearly rate of 18%. How many carp will there be in 10 years? So let's set up our equation. So A is the ending amount. That's what we're trying to find. Then our starting amount, P, 500. This is an increase. Population's growing, 18% as a decimal. And then we're looking 10 years down the road. So if I went ahead and typed that out on my calculator, exactly the way it looks, if I got a good calculator, you have to follow some order of operations if you don't have a good calculator. But if you do all that, you will end up with an answer of 2616.917777. Now, that answer is perfectly mathematically correct, but what the heck is a 0.917777 of a carp? Does that mean there's a carp swimming around out there with no head? Of course not. We'd have to, of course, round this to a whole number, which is a point that some of you still continue to miss on tests and quizzes when the real-life questions like this come in. Because, again, you're just not thinking logically. You're just doing the math. Math's important, but thinking logically is more important. So I'd round that up to 2,612 carp 10 years from now. Let's try one more. The number of people who have a landline phone, that's a hardline phone in your house, not a cell phone, has been decreasing at a rate of 10% per year. If 500,000 or 500,000 people have these phones today, how many will still be using them in 2050? So let's again set up our equation. A is our ending amount, which is what we're looking for. And our starting amount, 500,000, 500,000 people. This is a decrease. It even says specifically decreasing at a rate of 10%. So 10% as a decimal. And then my exponent. Well, I'd have to take 2050 minus 2020 and say, oh, this is 30 years from now. That's how much time will pass. So again, we got 500,000 people that have these phones. So I'm going to type 500,000. And then times. And what I ended up with is my final answer, 21,195.57914. And once again, what's 0.57914 of a house with a phone? It doesn't make any sense. We don't need that. So our final answer, 21,000, again, we'd round that to 196 people using landline phones. So again, in the next 30 years, it's almost like that could potentially drop completely off the face of the earth, minus a handful of holdouts, old people like me. Yay. All right, so that is your idea today. You're going to go through some story problems. Again, set up your equation. Go ahead and calculate things out. And then don't forget, in the end, most problems aren't going to want a decimal answer. Most real-world problems will be rounding to a whole number. But be careful. The decimal might be appropriate. And then again, in the end, make sure that your word problems have words in the answer. 21,196 what? So make sure those things have answers, that question, your number, and then what. What's that number stand for? All right, let me know if you need any help. You know where to find me. Good luck.